Hello everyone, I'm Nagraj, your Perf Test Coach. In this lecture, we will learn performance engineers vocabulary. When you talk to performance engineers, you hear below terms a lot. V users or virtual users, response time percentiles like 90th percentile, 95th percentile, throughput, peak load, concurrent users, bottleneck, correlation, parameterization, assertion, think time, and pacing. In order to understand performance engineers' language, it is very critical to know what these terms mean. So let me explain about these terms in detail. V users or virtual users. To understand what virtual user is, let us consider this example. Say we have an online banking application and we would like to know how this application behaves when 1 million concurrent users are accessing the application and are performing different transactions. Hiring 1 million real users and asking them to perform few transactions on our application at the same time is just not practical, and also it will be too expensive. That is why we use virtual users to do performance testing instead of real users. Virtual users will replay the recorded transactions during performance testing. We can use load testing tools to record different business transactions that we would like to simulate on our application, and these transactions will be recorded as a replayable script. We can configure the performance testing scenario something like below so that these V users can replay the recorded transactions. For make an online money transfer transaction, we want to simulate 10,000 transactions per hour. For add beneficiary transaction, we want to simulate 2000 transactions per hour. Similarly, we can configure the load for check account balance, check transaction history, and generate monthly statement transactions. If we run a load test after designing a scenario like this, all these transactions will be simulated on our banking application, and then we can use monitoring tools to analyze the performance of our application. I hope this concept is clear. Let us move on to the next topic. Response time. To understand what response time is, let us consider this simple example. Say we have a user who is trying to log into his Twitter account. He enters his login credentials and clicks on login button. A request is made to Twitter application server, which travels through the network and reaches Twitter application server. If the login credentials are valid, a response is sent back, which again travels through the network, and homepage is rendered on the browser, which the user will be able to see. In this case, the end-to-end response time can be calculated as browser rendering time plus network time plus processing time in Twitter application server. When we talk about response time, we should be very clear which response time we are talking about. Are we talking about the browser rendering time, or time spent in network layer, or processing time in application server, or are we talking about the end-to-end response time, which is the sum of browser rendering time plus network time plus processing time in application server? I hope this concept is clear. Let us move on to the next topic. Response time percentiles like 90th percentile and 95th percentile. To understand this concept, let us look at below graph. This graph shows the response time of 100 requests or samples. The average response time is 3.6 seconds. The 90th percentile response time is 5 seconds. The 95th percentile response time is 15 seconds. So what does this 90th and 95th percentile response time mean, and how to calculate this? In order to calculate the 90th and 95th percentile response time, we first need to sort the response time of these 100 requests into ascending order. The sorted graph looks like this. In this case, the 90th percentile is 5 seconds. The way we calculate this is, as we have 100 requests, 90% of 100 is 90. So let us place a red bar on the 90th request. If you observe this graph properly, the response time of 90 requests is under 5 seconds. So if we say 90th percentile response time is 5 seconds, It simply means the response time of 90% of the request is under 5 seconds. Similarly, we can calculate the 95th percentile response time as well. In this case, 95th percentile response time is 15 seconds. As we have 100 requests, 95% of 100 is 95. So let us place the red bar on the 95th request. Now if we look at this graph, the response time of 95 requests is under 15 seconds. In this case, we have response time data for 100 requests. So to calculate the 95th percentile, we place the red bar on 95th request. What if we have response time data for 200 requests? It is simple to calculate. 95% of 200 becomes 190. So we just need to place the red bar on 190th request. I hope this concept is clear. Let us move on to the next topic. Throughput. Throughput is nothing but work done per unit time. The unit of time can be per second, per minute or per hour. And the type of work done depends on where we are calculating the throughput. For example, throughput of web server can be measured as pages per second. Throughput of application server can be measured as transactions per second. Throughput of database server can be measured as SQL queries processed per second. Throughput of disk can be measured as IOs per second. I hope this concept is clear. Let us move on to the next topic. Peak load. To understand what peak load is and how we derive this number, let us look at below graph. This graph shows the number of orders processed on a typical business day. We have data for 12 hours, that is from 7 am to 7 pm, and it is very clear that more number of orders were processed at 1 pm. So in this case, peak hour is 1 pm. And we can see on an average 70 orders are getting processed every minute. So we can consider 70 orders per minute as the peak load in this case. If we consider this number as X, it is always recommended to do performance testing with more than expected peak load so that we can know how our application scales, and also we can be prepared for the order volume growth in future. So we need to test with 1x, 2x and 3x of peak load to know how our application scales. And for this example, I have considered data for only one business day, but usually when we are doing this in a real performance testing project, you might have to check data for whole month and then figure out what is the peak hour and what are the peak hour volumes. I hope this concept is clear. Let us move on to the next topic. I am Nagraj, your Perf Test coach.